Here we go. So the average position of the mass is that center, is what we're going to call the center of mass. And in one dimension, in that x direction, so I'll set here x at 0, this location of the center of mass, what I'm going to do is I'm going to create those little point masses that I used to be doing before. When I treated this box as a point mass, now I'm going to chunk it up into little itty bitty chunk, right? Into a little bitty chunk. So then all of these, so I will have here at x1, here at x2, I have a little bit of mass 1 at position 1 plus mass 2 at position 2 plus mass 3 at position 3, so forth and so on. But I need to end up with a position, and I have all this mass there, and then I'm just going to add up the whole thing. And then it's going to give me some position. Let's do an example. Let's stand. I'm going to have a meter stick here. I'm going to put this meter stick, mass of this stick is going to be, no, let's just build the stick. And we'll say it's all 1 centimeter, break this up into little 1 centimeter chunks. Each little chunk will be 1/10 of a gram. Where is the location? Where's the location of the center of mass of my meter stick? I know a lot of you have got a pretty good idea of where it's going to end up. And that's good. That's what I want you to have. So M1, X1, so it's going to be little mass 1. All of these are going to, the mass of each piece is going to be, what would I say, 0.1 gram. Right. So they're each going to be located at the 1 centimeter marks. So, wait, does that make it? Yeah, 1,000 this weighs 10 grams. Yeah, 100 grams. We'll make it 1 gram. Each little chunk's going to be 1 gram. And this is going to be, I'm going to have 100 of them. So chunk 1 is 1 gram. It's located, the first one's going to be located, what did I say, at the 1 centimeter mark? 1 centimeter mark, plus 1 chunk at the 2 centimeter mark, plus 1 chunk, 3 centimeter mark, plus 1 chunk, the 4 centimeter mark, plus 1 chunk, the 5 centimeter mark, and then I'm going to add up 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. Notice this is the total mass. I've got 100 pieces that are each a gram. All right. And now I've got to figure out how to add all of this up. 1 plus 2 plus 3 plus 4. Oh, man. Out to 100. I think Carl Gauss did this one. So 1 plus 99 is 100. 2 plus 98 is 100. I can do that 49 times, plus the last one, which is 100, plus the one in the middle. So I got 4,900 plus 100 is 50, 50. Did I do that right? So if that's located, aha. So I'm going to end up with 50-50. Location is going to be at the 50.5 centimeter mark. Why isn't it exactly in the center? Because I'm off by a little bit on this edge. I'm off by that ½ centimeter there on my first piece. All right. So you can see that I'm located right there in the geometric center of the piece. Man, that was tricky. Oh, wait. What if I did this another way? It wouldn't be at 1. It would be at 0.5. And then this one's at 1.5. This one's at 2.5. And then that last one wouldn't be at 100. It would be 99.5. 98.5. I bet I could figure that out. Anyway. What does that tell me? If I have a nice uniform bar, all of them are the same. The location of the center of mass is at the geometric center. If uniform, this is a huge piece of that. All right. If you have questions, go ahead and please type them in the chat. If you don't feel comfortable talking while I'm recording. All right. That's where that comes from. But next, let's do one that's slightly more complicated. What if I take that meter stick, which is, what did I say, it was 100 grams, 100 gram meter stick, and then I'm going to put a block over here. This will be located, this will be all of this is still one dimensional. Oh, that's 100 grams. We'll make this one 20 grams. And it'll be located out here at the 98, 2 centimeters, 1 inch. Yeah. The location of the block of this center of mass is at 98 centimeters. And then we'll put a little small one over here. Block 2, here's block 1, and then here's the meter stick. We'll put this one at the 1 centimeter mark, and this one will be 5 grams. Now, where's my new center of mass of the whole thing? We've got a question. What do I mean if uniform? If all of those chunks are the same, then the piece it's at the geometrical center. However, that's a super complicated. Let's find the center of mass of a baseball bat. And now that's not going to be uniform. That's a good question. So here we have, there's the handle, right? It kind of comes out like this, right? And then it comes out, and it goes out. That is a terrible looking bat. This cooch would kill me. So there's my bat. Bat's about, we'll make it 1 centimeter long, or I'm sorry, 1 meter long. Yeah, that's about a meter long. 1 centimeter long, or 1 meter long. But you can see it's thinner on this side than it is on that side. So this is not uniform. So I'm going to have to make some assumptions. Make some simplifications. So I'm going to treat this as a piece that's this big, a uniform piece that's this big. I'd probably go halfway through. So take some of this and some of that way, and then make this one so it becomes two cylinders that are uniform in themselves. This one's uniform and this one's uniform. And that handles about yeah, 10 inches, 25 centimeters. I'll make this one 25 centimeters, and this is 75 centimeters. And that's from there to there. And because now two uniform cylinders, the center of mass is located in the middle there, and the center of mass is located in the middle of there. So now I'm going to say the center of mass is going to be part A and part B is the mass of A located at the center of mass at A plus the mass of B, center of mass B, divided by MA plus MB. I never did figure out what the mass of that thing was. 2.5 kilograms. I think that's reasonable, mostly because I didn't. What is it? Mass of an average mass of a baseball bat. .4 kilograms. All right. I'll make it 1.5. Is that what that says? Today's bats, 1 kilogram, 1 kilogram. 1 kilogram. And that's the total mass of the bat. I bet, all right, if it was going to go this way, but my guess is probably 2/3 of the mass is over here. Is that right? No, more than that. If I broke it up like that, there's not a whole lot here. This has got to be 100 grams, 900 grams. All right. That sounds about right. So I've got the mass of part A, which is 100 grams. I wanted to use 100 grams because I'm dividing it out. As long as I use the same one for both, the location of my center here is at halfway along, which is 12.5, plus the mass of B, which is 900. And that's located in the center of 75, which is 52.5. But that's the distance here, and I'm measuring it from here. So the center is actually what is half of 75? 37.5. Yeah, that sounds right. So it's 37.5 plus 25 gets you 0.5 to. That does not sound right. $62.5. Doing this right. There we go. 62.5. Okay. Yeah. Divided by the mass of the whole thing, which is 1,000 grams. Now, where's the location of that center mass? Turn this on. The 100 times 12.5 plus 900 times 62.5. Did I get that right? That's 37.5. Okay. Divided by 57.5. How did I figure that? That means it's located 57.5 centimeters from this end. This is in centimeters, this is in centimeters. What's left is in centimeters. So it's from that end. All right, that makes sense. It's not at its geometrical middle. Right? It's not halfway down. It's another 4 inches farther out. Okay. That makes sense. That bats are, it's not in the exact middle. So there you go.